This is for exercise 31 from chapter 1. Question. For the vectors a and b in the figure, use the method of components to find the magnitude and direction of vector a plus vector b plus vector a minus vector b, and vector b minus vector a. First, we must find the components. The formulas used to do this are as follows. A sub x is equal to a times the cosine of theta, and a sub y is equal to a times the sine of theta, where theta is defined as the angle between the vector and the x-axis. So for vector a, we see that the a sub x is equal to minus 8 meters times the cosine of 90 in the i-hat direction. So that gives us a final value of 0 in the i-hat direction. A sub y is equal to minus 8 meters times the sine of 90 in the j-hat direction. This will give us a final value of minus 8 meters in the j-hat direction. For vector b, we see that the magnitude is 15, and theta is equal to 90 minus 30, which is what is shown in the figure. So our theta for vector b is equal to 60 degrees. So the x component of b is equal to 15 meters times the cosine of 60 in the i-hat direction. This will give us a final value of 7.5 meters in the i-hat direction. For the y component of b, it is 15 meters times the sine of 60 in the j-hat direction. This would give us a final value of 13 meters in the j-hat direction. In order to find vector a, or sum it up in components, we must add a sub x plus a sub y. Plugging these in, we see that a is equal to 0 i-hat plus negative 8 meters in the j-hat direction. This will give us a final value of vector a is equal to minus 8 meters in the j-hat direction. For vector b, we have to follow a similar process. Vector b is equal to 7.5 meters in the i-hat direction plus 13 meters in the j-hat direction. Now we put it all together and find the final solutions. Other formulas that we will use to find the solutions are as follows. The magnitude of a is equal to the square root of a sub x squared plus a sub y squared. The tangent of theta is equal to the y value divided by the x value. Or if you solve for theta, theta is equal to the inverse tangent of the y value divided by the x value. For part A, we must first find what a plus b is equal to. So we plug in for vector a minus 8 meters in the j-hat direction, plus vector b, which is 7.5 meters in the i-hat direction, plus 13 meters in the j-hat direction. Now we group these numbers according to which direction they are in, being the i-hat or the j-hat directions. So we have 7.5 meters in the i-hat direction, plus minus 8 meters in the j-hat direction plus 13 meters in the j-hat direction. And then we simplify. So a plus b is equal to 7.5 meters in the i-hat direction and a positive 5 meters in the j-hat direction. Now we must find the magnitude. We simply plug in the values we just found up above. So the magnitude of a plus b is equal to the square root of 7.5 meters squared plus 5 meters squared. We continue to simplify and see that the final answer is 9.01 meters. In order to find the direction, we must find angle theta. Theta is equal to the inverse tangent of 5 meters divided by 7.5 meters. This will give us an angle theta of 33.7 degrees. So that means that the direction is 33.7 degrees above the x-axis. For part B, we simply add vector b plus vector a. So that means we have vector b 7.5 meters in the I-hat direction plus 13 meters in the j-hat direction plus vector a, which is minus 8 meters in the j-hat direction. Once again, we group these up according to which direction they are, and we put the I-hat values first. So we have 7.5 meters in the I-hat direction plus minus 8 meters j-hat direction plus 13 meters in the j-hat direction. Simplifying, we see that vector b plus vector a is equal to 7.5 meters in the I-hat direction plus 5 meters in the j-hat direction, which is actually the same thing that we got for vector a plus vector b. So recognizing that it's the same, or simply plugging in according to what we found, we see that the magnitude of vector b plus vector a is equal to the square root of 7.5 meters squared plus 5 meters squared. This will give us the value of 9.01 meters. Again, this is the same that we found for vector a plus vector b. In order to find the direction, we plug in these values. Theta is equal to the inverse tangent of 5 meters divided by 7.5 meters, which will give us a theta value of 33.7 degrees, which means the direction is 33.7 degrees above the x-axis. For part C, we need to find vector A minus vector B. So we plug those in. Vector A, which is minus 8 meters in the j-hat direction, minus vector b, which is 7.5 meters in the I-hat direction plus 13 meters in the j-hat direction. So we group these up, making sure to account for the minus sign in front of vector b. So this means that we have minus 7.5 meters in the I-hat direction plus minus 8 meters in the j-hat direction minus 13 meters in the j-hat direction. So the final equation for vector A minus vector B is minus 7.5 meters in the I-hat direction minus 21 meters in the j-hat direction. To find the magnitude, we simply plug into the equation. The magnitude of vector A minus vector B is equal to the square root of minus 7.5 meters squared plus negative 21 meters squared. We simplify this and find that the magnitude is equal to 22.3 meters. Now we must find the direction. Theta is equal to the inverse tangent of minus 21 meters divided by minus 7.5 meters. When we plug this into our calculator, it will give us a value of 70.3 degrees. But please note that given that both of the components have negative values, it means that the direction is actually in quadrant 3. So in order to find our true theta, it is equal to 180 degrees plus our 70.3 degrees. So this will give us a direction of 250.3 degrees above the x-axis. For part D, we must find the value of vector B minus vector A. So we plug those in. Vector B is 7.5 meters in the I-hat direction plus 13 meters in the j-hat direction minus negative 8 meters in the j-hat direction. So we group these up as we have done each time, making sure to take note of the negative sign in front of vector A. So we have 7.5 meters in the I-hat direction plus 8 meters in the j-hat direction plus 13 meters in the j-hat direction. This gives us a final equation of 7.5 meters in the I-hat direction and a positive 21 meters in the j-hat direction. The magnitude of vector B minus vector A is as follows. The square root of 7.5 meters squared plus 21 meters squared. This will give us the same magnitude as vector A minus vector B, which is 22.3 meters. The direction is theta is equal to the inverse tangent of 21 meters divided by 7.5 meters. Since the components are both positive, we know that this is in quadrant 1. So the answer of theta is equal to 70.3 degrees is correct. So the direction is 70.3 degrees above the x-axis.